Hello everyone. Welcome to this session on integrating artificial intelligence or AI with domain-specific tools. My name is Philipp Langer. I work with Eclipse and Eclipse is basically a technology partner and service provider focusing on building specialized IDEs, custom tools, domain-specific modeling environments, and surely in the last 1 or 2 years, integrating AI capabilities in those tools became a very, very important and recurring topic. So what I would like to do today is to share the experiences we gained so far in integrating AI and domain-specific tools in general, and give you some really practical insights and techniques that we have applied. So there will be lots of demos. I will also even dare to show them live, even though it's conference with Wi-Fi and non-deterministic LLMs, but bear with me, we'll all go fine, I hope. All of these concepts that I will share are generic, so you can use them in any tool context. However, I will mostly show them based on Thea, which is a platform for building custom tools, and in particular a new framework that we've been developing called Thea AI, which helps you to integrate AI into Thea-based applications. But all the techniques are basically generic enough. So let's start. What is integration, tool integration of AI? So I'm sure if you've spent a few minutes on the internet in the past few months, you've heard all of these tools already: GitHub Copilot, Project IDEs, Cursor IDE, Codium, Claude Dev, and all of that. And those tools bring AI capabilities into your IDE in all sorts of forms: code completion, context-aware, chat windows, and all of that. And what really makes them special is that they go beyond tool-integrated chat windows, right? Because in a tool-integrated chat window, you as a user have still the task to come up with basically all parts of your prompt. What is actually the thing that I want to achieve? What is the context information that is required to propose a solution to achieve your goal, to add possibly additional context and task instructions and all of that. And then on the other side, just in a tool-integrated chat, you as a user would have the responsibility to apply all of these suggestions again in your tool manually, which is obviously not great. So where all of these tools that I mentioned before really add value is by the tool integration, in the sense of that they maximize the degree of automatic prompt composition, so that most of the parts of the prompt, except for what you want to do, like the user intention or so, is actually added by the tool integration, including task instructions, including context, including possibly necessary knowledge, and so on. And then on the other side, they want to maximize the degree of response actionability, in the sense that you as a user have basically just one click away of applying the suggestions that the LLM provides in what form whatsoever. And how these degrees can be increased is by all of these techniques that are shown here, like prompting strategies, context identification, augmentation, tool function callings, and so on. And I will discuss all of these techniques and how they can be implemented. So let's apply that to custom tools. We've just talked about code editors for now. What do I mean with custom tools? I mean tools that are specialized, optimized, tailored for particular use cases, and therefore they often come with domain-specific editors like diagram editors, form-based editors with an underlying data model, specific semantics and syntax, and so on and so forth. So we want to apply that to such tools. Because AI integrations in such tools can basically unlock the same great functionalities and capabilities and efficiency improvements like the things like Copilot for IDE. So that includes comprehension, fixing errors, auto-completion, and so on. So what I would show, just to kick things off, is a demo. Basically, this is a domain-specific diagram editor. Isn't really anything that is now specific to understand, but it's basically our representative example for a domain-specific editor, whatever this will be in your case. And on the left-hand side here, we have just a chat window, right? And what we want to achieve now is that this chat window really helps us understanding, editing, and doing stuff with this domain-specific editor. So for instance, we want to be able to ask now, for instance, how many tasks are executed in parallel at maximum within this document, within this diagram. And we, as software engineers, we kind of already know, okay, there is a parallelization or a fork node, so this means these two nodes can be executed in parallel. And now, with a good tool integration, the AI can understand that as well. It can not only read what is the state of the diagram currently, but it can also understand its semantics and can here propose the maximum number is actually 2. We can now also ask workflow, which ones? It was lazy, it didn't tell me, so I will ask again. Yeah, it is check water and check temperature, so that's those two, right? Excellent, so this works well. Of course, we also want to go beyond and actually do some editing, so let me just ask it to add 2 more task nodes here at the end, representing to, I don't know, serve the coffee now to the customer. Let's see what it does. Cool, it creates 2 new tasks and links them up. So that's also working very well. Another typical context is to also incorporate even more context than just the diagram editor that we see here. So for instance, we may want to ask, what does actually TP and WT, which is used here as abbreviation, stand for? So what the AI now does, it is accessing additional contextual information around this diagram, which is sort of like a something like a documentation here, and can therefore answer, TP stands for temperature and WT stands for weight. And how does it know that? Because underneath the diagram there is an additional file. In this case it's just a simple text file that I put here, where these definitions are being made. And of course now we want to maybe also adjust this additional context, but so we could say, for instance, now we could say, for instance, now actually WT is water and not weight, and we please update that now for me. And now the AI generated essentially a new documentation, updating all of that in the documentation file, and I could even then ask it also to update the labels. Let's say, for instance, here now workflow, please also update the labels in the diagram accordingly. Yeah, there is typos, but I guess the AI won't care about that. And you see here, it updated the labels. So that's what we mean by AI integration into domain-specific tools. It understands the context of the tool, it understands the semantics, it can work with custom editors and different operations that these editors provide. And this is actually the challenge of integrating AI in custom tools, because you need to deal with these specific semantics that the LLM potentially is not aware of. You need to interact with non-textual editors, the forms, trees, diagrams, whatsoever. And you don't just, like what LLMs can do really well is they produce tokens, right? But in this case, you need to produce high-level operations that are then translated into your editors. So that all means that the tool integration must carry even more weight than for generic general purpose IDE integrations. So let's have a look at how we can actually build something like that and how we can solve all of these issues. As I mentioned before, all the concepts I will propose or I will demonstrate are independent of the respective framework, but I will show that based on Thea AI, so I thought I will also give a few hints about what Thea AI is. So Thea AI is a framework that is part of the Thea project, which basically is a common platform for building custom tools. And Thea AI in particular enhances this platform by making it very easy to integrate AI capabilities into those custom tools. As part of being Thea, it is also open source, vendor neutral, and is really designed to give you as an adopter full control over everything in this AI integration, ranging from where and how the AI is integrated, which language models are actually being used, whether it's on-prem, something on the edge, or an off-the-shelf frontier model provided by some third party, which tool data is shared, and what the actual behavior of the agents are. And it provides essentially, here is a high-level overview. It provides a chat window. It provides an agent framework that is then can then use tool functions, variables. You can benefit from prompt management libraries and so on. And these agents are then capable of accessing LLMs and talking to them. And all of these violet, purple, I don't know what the color is exactly, these boxes are contribution points that are designed to be extended and provided by you with domain-specific implementations. And we will go through all of them in the course of this talk. So let's start with Thea agents. So a Thea agent, as you can also see here in this on this slide, It's really designed to be the mediator between your tool and the LLM. And with that, it sort of encapsulates everything in between, including prompting strategy, context augmentation, the LLM communication, tool actions, and so on. And there is two types of agents. There is plain agents. That's agents that can be invoked from anywhere in your tool, like a menu item, a command, or a custom editor. And there is chat agents, and those basically are agents that you can address with the chat window. So they need to follow a specific interface so that they can be integrated in the chat. Before I go into too much detail about agents, because they are basically taking care of the prompting strategy, I'll just give a very, very short primer on how an interaction with an LLM API actually looks like, just in case you have never seen that. So basically, the most fundamental thing that an LLM API provides is completions, and the idea behind that is you, as an user of this API, you specify a set of messages. Each message is then tagged by either it's a system message, it's a message by the LLM, or it's a message by the user. And this is essentially representing your context or your overall prompt. And then you take that, send that to the LLM, and the LLM will produce the next message, sort of the response to this conversation. That's basically all you need to know for now. What's important is that you as a tool integration or as an agent, you are completely responsible and in control of that. And that's really the important thing, because what that means, it enables the agent to control a lot of the prompt engineering around that. So it cannot just basically forward what the user entered into the chat, but it can put all things that it thinks will be needed to guide the LLM for a specific answer around the user input. And that's essentially prompt engineering in a nutshell. So you add there constraints, instructions to fulfill certain common goals. You may add additional information, context information that is needed for that goal. And you maybe direct the LLM to produce the response in a format that you can then best process in your tool again. So the fundamental thing, first thing to do in this whole prompt engineering area as an agent is typically you specify a system message. And the system message, as you maybe remember here, is just a message that you put on top of the whole conversation. And in this system prompt, you can essentially specify all generic instructions that are true for any incoming message. So what you typically do, and this is just a subset, is you basically specify a persona to guide the communication style of the LLM. You can apply in-context learning, so that means you add explanations about domain concepts that the LLM may need to understand for a good answer. So that, for instance, in this workflow example that I've shown, is introducing the task types, the semantics, how they look like in the diagram, and so on. Then you can add additional steps. For instance, if the user asks that, then you should first identify what is the type, then you think about that, and so on, and you give it instructions essentially. You can guardrail it to, for instance, say, if the question is about Trump, please don't answer, stuff like that. And last but not least, you can add instructions about the communication format that you expect. So how would that look like in Thea AI? It's super simple. You basically just write the system message or the system prompt, and then you specify an agent by subclassing a default implementation of an agent, return the system message, and that's basically all you need to do. And I will always, in each demo, I will do this step that I'm showing and assign it to an agent that we can directly address with a number, so that we can really play around with and see how each of that would impact, each change would impact that. So let me just close that. Don't save. I kept the Eclipse Automotive here. So of course, if we now go ahead and say, for instance, here, universal, so that's an unprompted agent. We ask it, it's always faster if I would just copy it. We ask it now here, what is the orange box? Obviously, it will just give you random stuff. It doesn't know anything about what an orange box is. But now, when I use this agent where we have specified the system message, obviously now it can answer it, right? Because now it knows the orange boxes represent manual tasks. So that's already the first in-context learning domain knowledge that we have added now. And we can, of course, also now ask it, what other types of tasks are there? And then it will go on and will explain me everything about automated tasks, manual tasks, and stuff like that. So that was the first simple step. However, even more important than that is additional context that you want to provide. In a tool, there is a lot of context. There is domain-specific knowledge, what we have already seen, but there is also context about the workspace, about the tool state, which editors are open, what is the diagram currently showing, maybe documentation and so on. And maybe the user is even referring to something specific, like what is the initial task of the diagram? What is the diagram, right? That's context. And you, as a tool integration provider, you are responsible of providing that context without the user being involved, essentially, in the ideal form. So the step is essentially you define a context format for that context, like Markdown, JSON, XML, doesn't matter. In the system prompt, that's the one that we've seen before, you explain how this format works so that the LLM can interpret what is the context. So for instance, how do you describe the diagram state? How can it understand it? And then you basically just augment the prompt. And that's super simple as well in Thea AI. There is basically the concept of variable providers, and a variable provider is essentially just a function that encapsulates the retrieval of specific information from your tool state, workspace, whatever. And once you define the variable, then you can essentially allow the user to use it manually or have an agent automatically use this variable. So let's stick with the workflow one. So that's the one that doesn't know the context yet. I will ask it now, what is the initial task? It will say, I have no idea, right? Because where should it have this idea? But if I now introduce this variable and I will answer it here, workflow, what's so difficult? Then it will suddenly say, yeah, okay, now I understand it. It's push. That's the first initial task, right? And that's how context works. However, of course, we don't want the user to always have to mention this variable, so we can create another agent that always adds the current diagram that is being opened in the tool, and suddenly it can give the same answer without the user specifying the variable. And all what you need to do that is specify this agent always gets this variable as well. That's essentially it. The difficulty, of course, is the variable provider implementation needs to read what is the open diagrams, access the diagram, retrieve the state, translate it in a format, and attach it to the prompt. But that's basically then the tool provider problem because that's domain-specific implementations that you need to provide that is specific to your tool. Right, so that's first set of context. However, there is an issue, right? If we always add the workflow diagram to the context, that doesn't seem very efficient because with a growing set and complexity of use cases, also there is an expanding range of different types of contexts, increasing volume of context, and we kind of want to avoid overfilling the context window of the LLM with unnecessary, irrelevant context all the time. Maybe because it also increases cost, but what's even more problematic, because of the lost in the middle problem, the more irrelevant content you add, the more you kind of bury the relevant context, and by that decrease the quality of the answer of the LLM. So you want to basically provide a spot-on context, and that's the challenge. So we need a dynamic way of selecting the relevant context based on the user request. And the most obvious or most popular way of doing that is retrieval augmented generation. I'm sure you've heard it. It's RAG for short, and it comes in many different flavors, but the basic principle is instead of having the user specify a query going directly to the LLM, you first go to another component, give it the query and say, give me the relevant information, and then you add this relevant information to the prompt. So that's the basic idea behind it. And for document-oriented use cases, vector databases and embeddings and similarity search is a good approach. But for other use cases, other approaches might be better, like generating a search query for a database or whatever. And for tools, at least in our experience, one approach that is very relevant is multi-turn prompting. Because in tools, you have very different sources of contexts. It could be documentation of a domain-specific language, could be the tool state, like which editors are open or which text is currently selected, could be workspace files and so on. And you really have to identify which of these contexts is now relevant for this user query. And then depending on that, you are either using, for instance, code maps to identify which files are relevant to be added and so on and so forth. So how that works is essentially you add a step in this whole thing. One typical approach is to classify the user input and basically say, classify the user input so that we basically specify which type of context is needed to answer this question. So the prompt could be classify user request, determining if answering the user request, this is the user request, requires the current diagram, this documentation, or some code. So that's of course a very simple classification, but just to give you the idea. And you give this to the LLM. You let the LLM do this job, and then the LLM basically should answer according to a specific output format that makes it easy for you in the tool to process. Basically to specify the requirement context for this question is the diagram. And these are maybe the search terms that you should use to even more narrow it down. And basically with this information, you then go to the respective context retrieval strategy, attach the context, and then you do all of that, what we've discussed before, and attach it to the prompt. So how does that look like? Now I'm showing code. We have to also show code from time to time. So essentially to implement that, you can add additional agents. So Thea AI, you can implement custom agents, and they can use each other, right? And here we added a classification agent that has exactly this prompt that I've just shown you. Classify the user request bibabo, give me this format. And this is what this classification agent does. It gets basically the session, then you get the system prompt, you add a progress message to show to the user, now I'm classifying, I'll get to you in a second. And then you essentially give it these messages and you specify the response format that you want. And that's called structured output. Not all LLMs support it, but many do. And this is super useful because you force the LLM to give you exactly this output format, which makes it very reliable later on to process. So this is what this agent does. And now our chat agent from before, now called 3, but it's essentially the same as the 2, it basically now first asks, instead of directly answering, it asks the classification agent, what is the classification for this request? And then based on that classification, I retrieve additional context. Here in this case, it's super simple. If it includes diagram, I will get the current editor, retrieve the diagram state. If it is documentation, I will get also the documentation behind it. And if it is code, I will just always statically return some random code. That could be more complex in reality, but it's just here an example. So how does that work now? When we go ahead here and, for instance, here ask this workflow 3 agent, what is the final task in this diagram? We hit enter. Now it's giving me progress information. It has classified it. And it will say it's true. Excellent. We didn't specify what context we actually need, but it still could answer it. What does the WT stand for? Now it's again doing the classification thing, and it can correctly answer that because it now went to the documentation. When I ask which functions are called in check TP, then it will probably give us the static code that we gave it before. Open can enable that. That's what we always return. So that's how these classifications work and how dynamically adding context works. Of course, this can be then much more complex, but this concept is exactly the same. Now, of course, next, what is super important is when you give a correct answer based on relevant context and in-context learning and all of that, you want to make it as easy as possible for the user to process this, right? You don't want to generate an abstract and the user would have to read and copy over stuff. So you want to make actionable responses, and how this typically works is in your prompt, you specify a format in which the LLM can give you tasks that you can then parse and execute in the tool. So for instance, we could specify if the user asks to create elements, then please generate something in this format, and then basically you as an agent, you get this format back and you parse it and translate it into a button that actually then performs this change. And that's what you basically do before you give it to the user. And how this is supported in Thea AI is that you as an agent can specify response content matcher, which is essentially start and end regular expressions, and then a function that translates that into some object, so that you map essentially the answer from the LLM into parts that are either, for instance, markdown, that are either commands when they start with this XML like create, then again markdown, then command. And so with that you create a model of the response. And then on the other side, on the UI side, before rendering it, it will basically map that to response path renderers. The Markdown renderer is rather just outputting it as Markdown, HTML Markdown, and if there is a command, it will render a button and register a handler for that button. So let's see if that works. How that works when I do that here, create new 2 reasonable steps. We've already did that before, but now we have basically prompted the LLM to create these things. Oh, is this the right one? Wait a sec, let me refresh. Yeah, now it works. Okay, now we get buttons back. And when I click those buttons, then we create actions. Still at 100% success rate. Let's see. So that's how you can make the response interactable. Of course, you can also use links where you then register open handlers to open editors, maybe jump to even elements and stuff like that. Right, the final thing that is a very common technique to be done is tool function calling. So the basic idea of tool function calling is you give the LLM a set of functions that the LLM can call. And with that, you don't specify to the LLM first do that, but you give this decision to the LLM and put it in a more agentic position to decide itself for which user request, which function it should call. And that's super powerful, of course, but you also need a very capable model that is being able to do that. So essentially what you do is you define a set of functions with input parameters, and then basically this is also then described in natural language so that the LLM knows when to call it and can guess when to call it. And then you register a handler in your tool, in your agent, that does something when this function call happens, and then you produce an output that is going back to the LLM. And there is many different use cases. For instance, letting the LLM call you to perform computations that you can do much better in your tool deterministically with code than the LLM could ever do, like computing overlaps graphically. So that's something that we can easily do in the tool, but hard to do or explain to the LLM. Or using the language services to retrieve a type hierarchy or something like that. That's super cool to be done in the tool, but hard in the LLM. Or let it obtain additional context, like the tool state or something like that. And that's really, really powerful. I don't need to demo that to you because that was actually the first demo that I showed that was entirely based on tool functions. And if you remember, you saw this ran get diagram, ran creating nodes. That was just basically tool functions. I will just show you how that looks like in code. It's really rather simple. Essentially, in the system prompt in Thea AI, you can list all available tools. And for each of those tools, there is then a tool implementation. And the tool implementation looks like this. So that's a tool. And you specify the name, a description. You define in this JSON schema-like syntax what is the input parameters. And then you register a handler. And in this handler, you actually do the job like creating a label operation, creating a node operation, and things like that. Right. So, of course, we just now talked about chat agents. There is also basically more types of agents. Basically, you can integrate an agent wherever you like in all other editors as well. For instance, in a custom editor, in the terminal, in in a context menu, however you like. Typical use cases is, for instance, auto-fixing issues and so on. So I can also just really quickly show you that. I don't save it. I will just open it, and here, if I remove this edge here, according to the language rules, there is then a validation error here. And I can now click and say fix with AI. And it will then figure out what it needs to do to fix it. It's adding an edge. It's now not so impressive, but actually what is working behind the borders or behind the surface is pretty impressive. Why is this so great? Because the user didn't have to phrase any question. She just clicked a button, and you have very good context information. You know exactly where it clicked, so the element that is wrong, you can attach the validation message, and with that get very reasonable responses back. So that's something to look out for. But you can, of course, go even crazier and do multi-agent systems where they communicate with each other and so on based on this framework. Right. And all of that, what I've shown you, of course, these are very simple examples, very simple showcases of the technique. Where it really then gets interesting, you can combine all of these techniques for your use cases. You can combine chat agents with non-chat agents. use variables, multi-term prompt flows in combination with tool calls, with complex content part rendering, where you even show parts of the diagram in the chat response that are then clickable to navigate to them and so on. So that's really all possible with the combination of these techniques and the combination of these Thea AI capabilities. And all of that is designed so that you are in full control of everything. I already mentioned that, from tool data, LLM selection, and so on. And it's even, you have full control over the UI integration. So for instance, you could go ahead and say, okay, a chat window is not what I want. Actually, there is much better ways to integrate, to interact with an AI. So I want to now enable the advanced AI mode. And then you as a tool provider can say, this is a better way to interact with AI. I can now use that, right? So that's full control. You can even do something like that. Decide yourself if you want to go with it or not. Of course, there's many more features, ranging from custom menus, prompt editing, and observing LLM output and agent logging, which is great for debugging and so on, but I don't go into too much detail for that, so please check it out on your own. I just want to close with a few recommendations before we go to questions. First of all, I would really encourage you to start with the tool integration for AI for your tool now, essentially. Start as early as possible and do it from the end to end. Keep it very simple at first. Use only prompt engineering and off-the-shelf language models. Try to basically get a use case done that already works and provides value, that doesn't require fine-tuning, setting complex RAG pipelines and all of that. Because this allows you in the end to learn and understand what data you as a tool provider you need to provide to the LLM so to get reasonable results, because this is the challenge. This is what's specific to your domain. This is where you can add a lot of value immediately. And this also means, and that's really an experience and a learning we have, you need to think about an API in your tool, not for the user, not for another component, but for the LLM. And you need to identify what that API needs to look at, because suddenly it is important to describe your schema in a way that an LLM can understand it. That wasn't necessary before, but it's now super important, and you need to identify those things. And then from this initial state, you can incrementally go on and further improve the quality, success rate, and the use cases. Of course, then things like adding an evaluation pipeline and so on is becoming more and more more important and so on. And this process takes time and learning. And this learning is really specific to your use case. So it's important to start with that, I think, as early as possible. So with that, I hope I could encourage you to start adding AI into your custom tools. Focus on your domain-specific functionality and use that and combine it with the capabilities innovation in Thea. So visit us and talk to us. We are happy to support you in your AI integration project and with all of our services, from consulting to development and sponsored open source development. So really, let's dive into your AI project. Looking forward to your questions. Thanks. Are there any questions? Yeah, they're in the back.
Hi, so great talk. Did you develop some agents that you use yourself as a developer? And if so, can you tell how much time does they really save for you? Like, how much development time do they save?
Yeah, good question. Yes, we did that. So there is, I mentioned Thea AI as the platform, as the framework, and on top of that, in the Thea IDE, there is experimental agents that we started to develop. We didn't spend weeks on developing them. It's more like what we think could work in the first run. That's what's already currently available open source, so you can use that today. I think it saves a lot of time in specific use cases. It can cost a lot of time in other use cases, and it is you need to gain the experience. What are the use cases that work well, and what are the use cases that don't work well? So, for instance, what works well is creating a scaffolded interface definition, set of interface definitions. You describe what you are dealing with. I have customers, they have first name, last name, and so on. Please generate something. And that is already 80% fine, and it would otherwise take a little bit of time to type it. What does not work is, here is my 5,000 line JavaScript file. It seems there is a bug, please fix it, doesn't work. It also doesn't work to do something very complex in one step. So it's always then better to basically design smaller functions that do simple tasks. And for those use cases, it works pretty well. So what I often do is then I generate a function, then I go back and say, please generate test cases for that function. Then I manually augment those test cases to what I think the function should do. Then I go back, run the test cases, and give to the LLM the results back and say, please fix the test cases. And this is now really good context for the LLM to produce something valuable. Any other question? I use also LLMs for prompt engineering quite a lot, because essentially what prompt engineering is you need to explain based on common knowledge, a domain-specific knowledge to the LLM. It doesn't have to be entertaining, so it's not really a writing skill, but it has to be clear. And you can just hack a first system prompt, for instance, how it comes to your mind, into the LLM. Then you say, these are possible user questions, please provide answers. And then you say, I didn't like the second answer, always answered like that. I didn't like the third answer, because you need to do that. Now please adjust the original system message so that it's clear that you should have answered like that. And with that, you gain in an interaction with the LLM to find out what is the best system message for a specific use case. So that's where I also use LLMs a lot. Right, if there is no further questions, thank you very much. Enjoy the rest of the show, and see you soon.